So valence electrons are very related to electron configurations. It's basically talking about a subset of the electrons. So when we talk about valency, or we asked how many valence electrons, we're talking about remember we've already determined that elements in the same chemical group have similar chemical properties. Also, it turns out elements in the same group have the same number of valence electrons. And so valency is highly related to the chemical behavior. And we will use valence a lot the rest of the semester. So the valence electrons is the number of valence that are in the outermost level. So by outermost level, we mean the highest occupied N value. And there's a couple of tricky ways that we can get to getting the answer quick, but we do need to understand that it's the electrons in the outermost level. So the highest level of N that has electrons in it. So we have to write out the electron configuration, look for the highest value of N that has electrons in the electron configuration, and then count all the ones in that level. So that would be really our S and P electrons, it turns out. The valency of transition metals is a little bit complex because even though the d electrons will be in a lower level N group, we've already kind of discussed a little bit about this penetration. We're going to discuss shielding. It kind of gets a little complex because even the reason why we use valence electrons and why we care about valence electrons is it tells us about chemical behavior. The valence electrons are the ones that are going to participate in bonding. And it turns out that in the transition metals, some of the d electrons, which are not considered valence electrons, still do participate in bonding. And so it's an ugly sort of concept that different chemists will treat differently. So we're not going to talk about them because I don't want to get into it. But it turns out, if we understand all about those blocks of the periodic table, that the valency is related to this group. So it's the last digit of an element's group. So we can get to the answer quickly by simply saying, finding the electron, finding the element on the periodic table, looking at its group number, the ones where we use the group 1 through group 18 notation, and take that last digit of that number, and that's the number of valence electrons. So it can go any number from 1 through 8. That's the way to get to it, but you should understand what it is. It is the number of electrons in the outermost level. We can get some isoelectronic electron configurations. We talked about this a tiny bit in class. Two particles with the same electron configuration are called isoelectronic. They have the same number of electrons and they're in the same orbitals. The electrons are sort of similar. So we would expect these to behave similarly. Now you can't have two elements with the same number of electrons because if they're neutral and different elements have different number of protons, then they wouldn't have the same number of electrons. But you can have an ion and an atom be isoelectronic, and you have two ions that can be isoelectronic. So when you hear that term isoelectronic, know that it means the same electron configuration. So we talk about then predicting the charge of an anion, and we can do this off of knowing what the valence is. An atom will prefer a full valence shell, and it turns out if you go back and analyze, that's going to be 8 valence electrons because the S and the P will be in the highest N value. The d electrons will actually be in a slightly lower N value, even if they're towards the top, and same thing with the F. So it's really just going to be the S and P orbitals. The S orbital can hold 2. The P level, because there's 3 orbitals, can hold 6 for a total of 8 valence electrons. Ions, again, are not really stable things, right? They're charged, and charged things have an instability. They need to be neutralized with another opposite charge. So I can only make them under certain conditions, but there's an advantage to be an ion. So we're going to find that an awful lot of the time we're going to see ions being created, but they can't be created any old time. So an ion is only going to make an ion that's going to give it 8 valence electrons, and only when it's in the right environment where it can be neutralized by an opposite charged ion. So this is where we're heading in the bonding unit. That's what's coming next. So we really just practice by, I'm going to give you an element. You tell me how many valence electrons it has. You should also be able to do it if I give you an electronic configuration, you don't know what it is. But if I just ask you from an element, you should be able to do this very easily. We'll practice that in class.